I'm going to talk through how I did this question, and then at the end I'll talk about how the solutions did it. They're slightly different, there's definite overlap, but I think my argument is sufficient. So we've got a grid of 3 by 3 and then the numbers to put in. Now some of them, we just can't times them together to get a multiple of 4, like 1 times 3 times 5, not going to get a multiple of 4 because there has to be a factor of 4 in there. And so the only multiples of 4 in this list are 4 and 8. And then the only other way of getting a multiple of 4 is going to be by timesing 2 by 6, because 6 is the only other number that's even along with 2. But yeah, it's got to be these two combined. So these are the only ways of generating multiples of 4 in the rows or columns. So we must have 4, 8, and 2, 6 as a pair in different columns. E.g. 4, 8, and then 2, 6 somehow here. That would allow me to then fill in the rest of it. It doesn't really matter how. I could do 1, 3, 5, 7, and 9. And I'll be guaranteed a multiple of 4 here, here, and here. But we must also have this in different rows too. And it is not possible to have both. Like, because I put the 6 and the 2 here, but now I need to have the 6 over here, but I can't do both at the same time because then I wouldn't have it in the column here. So it is not possible to satisfy both conditions. And therefore Dean's task is not possible. Okay, now is that sufficient? I personally feel like it is. Someone will have to explain to me why it's not. The solutions, I do like them, to be fair, but it's a lot harder to see this. They use an idea called proof by contradiction, which is, it's a bit harsh to expect you to do it this way, to be fair, because this is actually tends to be, it didn't even used to be on A level when I did it, but it's come into the second year of A level. It's not that it's like a really difficult. It's just quite a profound idea. But it is worth, if you're interested in these sorts of problems, it's worth looking into these sorts of things, how you can prove that there's an infinite number of prime numbers. That's a classic one, as well as the square root of 2. So look those up. Actually, I've got videos on this on my website with which go through those. So try and find them proof by contradiction. So here, the solutions use proof by contradiction. They explain in a similar sort of way that only one row will contain 4 and 8. Um, and so there's going to be a row that contains neither 4 or 8. And therefore, this row is going to have to contain both 2 and 6. So they then say, in a similar way, we've got to have a column that doesn't contain 4 and 8, but then that is going to have to contain 2 and 6 as well. And as a result, they're in the same row and in the same column, which contradicts rule 1. It's very subtle, this contradiction, but we're assuming all the rules are being followed, and then we're saying that actually the only way that the numbers can be put in is if we put 2 and 6 in the same row and the same column, which is impossible and contradicts rule number 1. Therefore, it's not possible. So it's like I was saying, it's very similar to my argument, a bit more like rigorous, I'd say, than what like my argument, but I'm still happy with mine, so I'm sticking with it. Anyway, hope that makes sense. Both methods, I think, are okay. If you're erring on the side of caution, then maybe go with this contradiction one, and definitely look into it because it's a great method of proof.